Now, the test circuit is basically a circuit which contains a voltmeter and an ammeter. And this voltmeter and ammeter, it allows us to measure the current and the voltage or potential difference and current and potential difference at the same time. So an ammeter measures the current, a voltmeter measures the potential difference or voltage. I like to use the word potential difference these days because it's the difference in push between one of the sides and the other side there. And you always measure the potential difference across the component. Now, in this case, it's let's say it's a 10 ohm resistor. There it is, and as it goes across, there's a relationship between the voltage and the current, or the potential difference in the current. It's a very famous equation, V equals IR. Now, just to rearrange that again, so we've got R equals V over I, which is probably the most useful of them all, I would say, because it comes up quite a lot, but you need to just be able to rearrange it anyway. We've got I equals V over R. So those are our three different versions of this equation. Now, doing the same as we did before, so voltage, that's potential difference, and that's in volts, capital V, because it's named after a person, Mr. Volts. There's your current again, that's in amps still, and that's resistance. Now it's in ohms. The symbol for ohms is an omega symbol, ohms, OHMS. Okay, and there's your equation, V equals IR. Now let's have a look at this circuit. Let's imagine we've got 2 amps going through this circuit. Let's work out the potential difference we can push along with as we go through here. So first of all, we're working out the potential difference, so we need the equation V equals IR. So let's put the numbers in. First of all, 2 amps times by, and it's 10 ohms we're measuring in this case, so the potential difference is 20 volts, and that will be 20 volts. So this reading there will be 20 volts. Okay. Now let's just have a look at this resistor. And that 10 ohm resistor is special because it's 10 ohms no matter what happens. Doesn't matter if it's hot, cold, wet, dry. It's 10 ohms and it never changes. Now other things in circuits, they do change, and they change, and there's quite a few little experiments we now use with this so-called test circuit. Now I just want to zoom in a little bit on this part of the test circuit because you might occasionally see somebody put in one of these into a test circuit, which is a variable resistor. Now you might see it put there. You might also see it put next to the battery here, and it doesn't matter where you put it. And basically what this is, that section there, is a little bit like a power pack. And that power pack has got a power source on it, and it's got a variable resistor. So if you want to change the output, you move that variable resistor and you slide it up. So if it's got a lot of resistance, it produces not many volts. If it's got a lot of current, if it's got not very much resistance, it produces the full amount of push, if you like. So this variable resistor and that together, it's a way of altering the circuit. Now, in our power packs that we've got, we normally just get a power pack, and the picture of the power pack, it's got like a dial on the front. It says 1, 2, 3, 4, 5, 6, 7, 8, 12 volts or something like that on the power pack. Or occasionally we've got one of these ones with loads of different holes in it where we've got to put the wires in like that. All that does is it's got a variable resistor in there which changes the output, and that's all it is. So if you ever see that variable resistor next to the battery, that's what it does.